Howdy, y'all. This is the walkthrough for your second check-in assignment, so your project 2 assignment. And again, this is the one that I did last year with my group. So on your first page, you're going to pick one of the 3 projects that you turned in for your last check-in. So for my group, we decided to go with the finger prosthetic because we thought that it was going to be the best one for us to do, the easiest to do, and also able to give us the most usage out of all of the CAD components that we needed to include that I will get to later on in the presentation. So you're going to elaborate a little bit more in this part over what's part of your project. So for our project, we have, again, like you have in the last presentation, you have your problem, your solution, and your stakeholders. So we included how many people in the US go through amputations, and specifically what percentage of them have finger amputations, which is what we're trying to focus on this, and the projections of it. So you can see that it's a pretty common thing to happen, and it's only going to get worse as the population continues to grow. And usually they're expensive and they're pretty big, so it's not as feasible to have as an everyday thing. And so into the next part, we go over our solution, where how we were going to fix this problem. We wanted it to be low cost. We wanted it for anybody to be able to print it at home if they need it. So we decided to go into a 3D printed finger that could be changed at home and personalized. If you know anybody for it or who has a 3D printer, or if you just want to allocate it out to some sort of facility that has 3D printers, and just give them your measurements and they can 3D print you a finger. And here we have our stakeholders. And then here is a basic kind of drawing from our last presentation of generally what we were trying to do. Again, we didn't end up going this route because the physics of it didn't work the way that we wanted to implement it onto the finger. And on one of your slides, you're going to list out all the features that you think you're going to use. This is very preliminary. It's almost certainly going to change. We ended up using most of these. I don't think we ended up using freeform or surfacing on our final project. And it's completely fine if you don't end up using the same features that you say you're going to use in this project, because you're going to develop multiple different versions of it. And if it changes, it changes. As long as you have a good finished product, that's completely fine. And here are the technical requirements. You didn't have to have them on the last check-in, but you certainly have to have them on this one. And you really want to think about these because they're very important, and they're going to determine what simulations you're going to run. So since we developed a prosthetic finger, we wanted it to be able to be used in everyday activities. So if you're cooking or you're lifting things or you drop something on it, we want it to be able to withstand life. We want it to be, for lack of better words, life-proof. So we decided to go with 3 major studies: a thermal, a stress, and a fatigue study. So our thermal study, we decided for, so that if you're cooking, if you put it in the oven, it's not going to melt right off your hand, because that wouldn't be very good if you have a prosthetic finger and then you go to put some chicken in the oven and now you don't have another finger. That would be bad. So here you see that we have different types of materials and their different melting points, like what their thermal resistance is. And then we have our stress studies, which is for crushing, pulling, pushing of the finger, just to make sure that it can resist that. And then for our third one, we went with the fatigue study, which is kind of a derivative of the stress studies, where you're applying the stress study over and over and over again for a certain amount of cycles to see if it's going to break. And that is so that we could test for longevity. And here's your technical research. So for this one, you're going to want to find studies that have been done that are similar-ish to your current project, because expect you to just make something novel right away, because that takes years and years in research to figure out. So all you have to really do is kind of look for a study that did something similar to it, or is going to at least be conducive to your simulations. So for stress and strain here, so there was a 3D printed hand at one point in time that was similar to the finger that we were trying to design. And they did a stress strain study of pulling the finger, pushing it, and where in the different linkages are they able to, or was the most force applied, and where it was most likely to fail. And through that study, you could see that it was maxing out around 8% above or before the failure point of the plastic that was used in it. And now here is also another very important thing for this project. It is the classifications of your medical device. So if you want to figure out where your medical device is and what its classification is, you can go over to the classification. This one. You can go over to the FDA website, and you can see all this. So depending on what your device is classified under, you would select this. So for ours, it is a orthopedic, because it's for fingers and feet. So you click on orthopedic, and then you would scroll through here to figure out what it is. So here you can see ours is finger joint metal polymer constrained cemented, or so this one is polymer constrained. So you click here, and then this would be your classification. So you would just write down what the sub part is, what its major classification is, and then the section. And then if you want to give a little description of what's going on with it. And then from there, you have to talk about the risks of your of your project. So if something is getting implanted into the body, you could say possibly it could be rejected. It could cause some sort of irritation. It could cause some sort of abrasion inside of the body, abnormal bleeding, things like that. So for ours, since it was going on the hand, there's not really, or on a finger, there's not really a whole lot of risk in it, but it can be a little bit irritating if it's not fitted right, or if you just kind of jam it on in there, it can cause cuts and abrasions. And then you have your joint damage. So since it's a prosthetic finger, it's not going to distribute weight the same way as a normal finger, so it may cause some down the line issues with other fingers, joints, and the wrist. But you can mitigate that by designing it a certain way. And then here's our preliminary design, and you're going to label what parts or what features you're going to use at what parts. And again, you don't have to worry if you don't stick to this design. In your final project, you just have to make sure that you label out your thought process to your final design. You have to show what's your preliminary design, some intermediate steps, and then how did you get to your final project. And here's our sources page. Make sure to cite everything. And that is it for the project 2 assignment. Good luck, everybody, and I'm looking forward to seeing your projects.